Example 4 is going to require a little bit more work, but you know what? We're going to make it work. So, taking a look at this, we got 8 plus the square root of 3x minus x equals 0. My advice is get that radical, get that square root all by itself to start. So I'm going to subtract 8 from both sides and also add x to both sides. So on the left side, we're left with just the square root of 3x. On the right side, we're subtracting 8 but adding x, so we're going to get x minus 8. Now to solve for x here, we got to get rid of that square root, so let's square both sides. So we have 3x over here, and on the right side, x minus 8 squared is x minus 8 times x minus 8. To clean up that right side, we're going to do x times x, giving us x squared. X times negative 8, but also negative 8 times x. We get a grand total of negative 16x. Negative 8 times negative 8 is positive 64. And the left side is still 3x. So we got 3x equals x squared minus 16x plus 64. Let's get everything on the same side. I'm going to subtract 3x from both sides, and we end up with 0 equals x squared minus 19x plus 64. Now, ideally, at this point, we would try to factor. We're going to look for two numbers that multiply to 64 and add to 19. Well, factors of 64, we got 1 and 64, 2 and 32, no, not 3, 4 and 16, 8 and 8. That's about it. None of those are going to work. We're stuck with a quadratic that's not factorable. Does that mean there are no solutions? Nay. What it means, we need to go back to our good old quadratic formula, which is hopefully ingrained in your brain forever. It's the x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times our a value. In our case here, our negative b, our b is negative 19, so I have negative 19 plus or minus the square root of negative 19 squared. Let me zoom in a little bit. So I got negative 19 squared minus 4 times our a value, which is 1, times our c value, which is 64, all divided by, that's all I'm going to square root, sorry, all divided by 2 times our a value of 1. Yikes. Whatever. We'll make it work. So double negative 19 gives us positive 19. Sorry, there's a stray mark there. So we got positive 19 plus or minus the square root of 19 squared, folks. Go ahead and use a calculator. That's 361. Minus 4 times 1 times 64. You can use a calculator on that too. You might even be able to do it in your head. It's 256. All that divided by 2. So we got x equals 19 plus or minus 361 minus 256 is 105 divided by 2. Now, 105, not a nice square number. So what we could do is 105 doesn't have a whole lot of factors. Really, it's like 3 times 35. Yeah, there's not a whole lot going on there. 7 times 15. That's about it. So what I'm going to say is let's split it up. We have 19 plus the square root of 105 over 2, and the other one's 19 minus the square root of 105 over 2. Those are pretty solid answers there. They're not the prettiest answers you'll ever see. Now, if you wanted to plug them into a calculator and round to 2 decimal places, this is like 14.62, and this one to 2 decimal places is about 4.38. Yikes. Let's move on. Hopefully we will get nicer numbers in the next one. And we will. So, next up, we have 3 times the third root of x equals the third root of 7x plus 5. Whole lot of third roots going on. What I'm going to suggest is we take the third root of both sides. Now on the left side, we got to do the third root of both pieces. So this is one single term, 3 root 3 of x. Or sorry, 3 times the third root of x. So we're going to have to do 3 cubed, which is 27. And then the third root of x to the third power is just x. On the right side, the third root of that whole thing is just 7x plus 5. So this ends up being actually kind of nice right off the bat. To solve for x, we're going to subtract 7x from both sides. And we got 20x equals 5. Now, common mistake here. People will see 20, people will see a 5 and be like, boom, x equals 4. Careful. Make sure you're actually solving properly for x by dividing both sides by 20. And on the left side, we're just left with the x. And then 5 over 20, that's a reducible fraction. Both 5 and the 20 are reduced or divisible by 5, so we get 1 over 4. So x equals 1/4. Last one, let's crank this one out. Similar in nature, but it's going to have a rational exponent. We got 4 times x minus 12 to the 1/3 power equals negative 16. If it helps you to think about this left side as 4 times x minus 12 to the 1/3 power, that's the third root of x minus 12, and kind of using that same pattern that we had earlier to the first, equals negative 16. My advice would be divide both sides by 4. So that way we have the third root of x minus 12. I'm not going to bother putting to the first power anymore. Equals negative 16 divided by 4 is negative 4. Now to keep solving for x, we got to get rid of that cube root, so we're going to cube both sides. The left side, the cube root and the cube cancel out. We're left with x minus 12. The right side, negative 4 to the 3rd power. Negative times a negative times a negative. Still negative. And it's going to be negative 64. To figure out our x value, we're going to add, let me switch colors, sorry. We're going to add 12 to both sides. And we end up with x on the left side. Negative 64 plus 12 is going to give us a grand total of negative 52. Put a box on, we're done.